Hello everybody. Today we calculate the volume of the torus. Okay, so basically torus is like the center point, r distance. You have circle, right? But from top view, it's going to be like this. And here's R, and we take a slice of disk, right? And this distance we say dr. Okay, so this angle is going to be d theta, right? So this disk is pi r squared area. You multiply by this disk thickness is a volume, dv. So volume is going to be pi r square 0 to 2 pi, right? This dr, this is the volume, but this is the theta, so it's going to be 2 pi 0 pi r square d theta. Sorry, it's a mess here. R square and r, this is a radian angle, so r d theta is a dr. Okay, so this is constant all along the integral, so it's going to be 2 pi square r square r. Okay, simple, right? It's so simple, but you have to be careful here. This disk, actually, if you look at disk, disk is like that, right? This is R. This is smaller. This is larger. This is not the disk. Say this is delta r. Delta r, it's not exactly the disk. It should be like this. Let's see. Let me write more precisely. Disk should be flat from here to here, same width. Otherwise, you cannot claim dv is area times the width. Why you take this width? You can take this width, or you can take this width. Why you take the one in the middle? We need a little bit more convincing argument here to say this integral is correct. So what do you do? When you slice it, consider this way. Tell you the counter argument first, okay? Suppose you have length d and you draw the semicircle. This semicircle is 2 pi d divided by half, so pi d, right? Okay, you divide this into half, right? So this is gonna be half d. The semicircle is going to be half d pi. This is half d pi. So this length and this length is same as this, okay? You divide this again, okay, and you divide this again. If you do n times infinite, what's happened? This semicircle become on this line, okay, and become D. This argument is wrong because even no matter how many times you do, total length is still pi d. Even it look like just straight line because this bump disappear when n equals infinity. Okay, so you cannot say, well, you know, we take this slice small enough, it's going to be area times this t. How about area times here or here? What happened? You need to be a little bit more convincing, the argument, right? This, you cannot just say, hey, it's gonna be okay, it's gonna be this disk volume is going to be, if it's thin enough, become this, so we can take a integral. You can say that. Okay, so we add a little bit argument to convince this here. This torus we divide into n, and n is even number. Okay, so if I emphasize how it look like, this is one piece, right? This triangle, this portion is missing because it's torus. Okay, we stack next one opposite, and we stack next one opposite, and we have even number, so it's become kind of rectangle, right? Okay, then n goes to infinity. What's happened? If we take this length, we add up this length, same as this side, which is this length and this length, you add up r minus r plus r plus r divided by 2. So r. Okay, so taking this middle point is very appropriate. This is r, right? You take this one, you take this one, when n goes infinity, it becomes same length rectangle. Only remaining question is, will it be complete rectangle when n equals infinity, or still have some tilted parallelogram? Not really, because when n goes infinity, this become 90 degree, so it's going to be rectangle. Okay, so what you do is you take a middle point and take an integral of this all slices. It's going to be okay because this one compensated by this, you go around, and it's become this. Okay, one thing you have to be careful in those geometric integral. Sometimes we often use visualized kind of common sense, which is not mathematically correct, because even no matter how many times you divide this semicircle and this semicircle become almost flattened, total length is still pi d, not the d. It never go to d. Okay, so you can't just convince saying, oh, this look like a flattened line, so it's become d. No, that's a false argument. And this is very convincing argument when you do this. Okay, you stack up opposite way. and total length is going to become this pi r, the half of the total length. Okay, so that's a way. A little bit be careful when you claim integration. The delta r, this delta r, the when n goes infinity, you integrate. It has to be justified. You cannot just claim, oh, it's going to be okay. All right. Okay, if you like this video, please subscribe and wait for the next one.